Good day, grade 9 students. How are you today? I hope that you're doing fine. It's another great day to learn new things. This is teacher Jason F. Anthony in Science 9 of Santa Ana National High School. Before we will start our lesson proper, may I request that everyone is watching today to relax your mind, meditate, and focus to our topic. Be sure that you are seated comfortably and can clearly listen to this broadcast to understand clearly with our lesson for today. Do you have with you your module, periodic table, ball pen? And that's good. You have previously learned that substance or element is composed of indivisible particles called an atoms. Then, you also learned that an atom consists of three subatomic particles. Namely, we have neutron, proton, and electron. Our topic for today is based on most essential learning competencies of the Department of Education, which is to explain how the quantum mechanical model of an atom describes the energies and positions of the electrons. These are the learning objectives of today's lesson. At the end of the lesson, you are expected to first explain the development of quantum mechanical model of an atom. Second, state the persons behind the development of an atom or quantum mechanical model of an atom. Third, define electron configuration. And fourth, determine the correct configuration of a given element by following a certain rules in its orbital diagram. Be sure that at the end of the lesson, you will attain the desired objectives. At this point, prepare your SLM or self-learning module and have you try to imagine what an atom really looks like along its subatomic particles? Or do you wonder how scientists develop the atomic model? Let us consider the development of quantum mechanical model of an atom and how electrons are arranged in different orbitals. Let's find out. The works of the following scientists led to the development of quantum mechanical model of an atom. One of them is Ernest Rutherford. Do you know who is Ernest Rutherford? In 1911, he proposed that an atom has a small, dense, and positively charged nucleus. Electrons move around the nucleus. Next, we have Niels Bohr. Do you know who is Niels Bohr? A Danish physicist who proposed that electrons are found in definite orbit. Three scientists led to the development of quantum mechanical model of an atom. We have Louis de Broglie, Erwin Schrödinger, and Werner Heisenberg. Louis de Broglie, a French physicist who proposed that the electron, which is thought of as a particle, could also be thought as a wave. Next, we have Erwin Schrödinger, an Austrian physicist, who developed a mathematical wave equation based on de Broglie's concept of particle as a wave and used it to describe the hydrogen atom or quantum mechanical model. And last, Werner Heisenberg. Werner Heisenberg is a German physicist who discovered that it is impossible to locate the exact location and momentum of the electron, which is also known as an uncertainty principle. Those are the scientists played a vital role in the development of quantum mechanical model of an atom. What is a quantum mechanical model of an atom? Quantum mechanical model of an atom is an idea where electron views as a cloud of negative charge having a geometrical shape or so-called orbital. This model provides a better way of understanding of where the electron would likely to be found in the different locations surrounding the nucleus. Orbitals have different shells or energy levels. The farther the energy level from the atomic nucleus, the higher its energy. In quantum mechanical model of an atom, the wave function predicts the three-dimensional regions of probability where electrons are likely to be found, as you can see on the diagram or presentation. And this region of space is called an orbital or shell. In every energy level, there is a specific number of orbitals. In each orbital, there is a specific number of electrons that can occupy. Energy sublevels are contained within the principal energy level, as you can see on the diagram or presentation. Okay? Wherein it is represented in an energy level or principal energy level, n, which is equal to 1, 2, 3, and 4. The farther from its nucleus, it means the farther or the greater its energy level. Okay, whatever would be its principal energy level would also be equivalent to its sublevels. Energy sublevels are contained within the principal energy levels. Each energy sublevel relates to orbitals of different shape. Atomic orbitals are three-dimensional regions with a high probability of electrons. Shape of orbitals. It is represented by letters, namely we have S, P, D, and F, that can contain different total number of electrons. There is one S, okay, for shape of an orbital. There is one S orbital which is spherical, as you can see on the diagram for presentation. Okay, for p orbitals, okay, there are three p orbitals which are dumbbell in shape. There are 5 d orbitals. 4 are shaped like clover leaves, and 1 is shaped like a dumbbell with a donut around the middle. There are 7 for f orbitals. Okay, it is presented in terms of tabular form. Okay, the summary of principal energy levels and sublevels and orbitals. The first column is principal energy level or principal energy level. Okay, as you can see on the diagram or in table manner, n, which is equal to 1, 2, 3, and 4. Okay, whatever would be its principal energy level would also be the same of the number of sublevels. As you can see on the diagram, okay, n1, same as for sublevels 2, 3, and 4. Okay, type of sublevels and the maximum number of electrons. Do you have any questions regarding on how we quantify the maximum number of electrons? Okay, based on representation, we have 2, 8, 18, and 32. Do you know how to get it? You can use the formula of 2n squared. Okay, you can replace n by its corresponding principal energy level. For example, we have 1 can be replaced into n, and therefore raised into second power. Okay, 1 multiplied by 2, and that's 2. Okay, and so on for 8, 18, and 32. Is everything clear? If yes, let us proceed to lesson 2, which is electron configuration. What is an electron configuration? It is the arrangement of electrons in an atom. It serves as the fingerprint of the atom or element. The table shows how the electron is arranged. Okay, we have sets of elements, namely we have hydrogen, helium, lithium, and boron. Okay, as you can see, based on its energy level, 1s, 2s, 2p, and then for electron configuration or orbital diagram. Okay, for hydrogen, 1 arrow, one electron. That's why 1s1, 1 there, corresponding to its exponent. Helium, 1 up, 1 down. If you have some question, what does it mean with up and down arrows? It means it is a spinning or spinning in opposite direction. 1 up, 1 down for helium. That's why for orbital diagramming for electron configuration, that is 1s2. Okay, same with lithium. We have Li3, 1 up, 1 down, 1 up. That's why for electron configuration, we have 1s2, 2s1. And last, boron. Okay, which is 5, 1 up, 1 down for first energy level. Then for second energy level, we have 1 up, 1 down. And then so on for p orbital, 1 up. To count it on, that is equal to its atomic number. How to determine the electron configuration of a given element? That's the question. Okay, first step. Find the atomic number of the given element by looking at your periodic table. Atomic number. For example, carbon, which is 6. 6 would also be equivalent to the number of electrons for carbon. Second step. Following the 3 rules. We have Upbow, Pauli's, and Hans rule. Always start filling up at 1s, following the 2s, 2p, and so forth, until you reach the last number of arrow or electron. In each orbital with its configuration, always write first the upward before the downward. Third step. After filling in the boxes correctly, according to the Hans rule, write only the configuration with an arrow following the Pauli's rule. And lastly, write the number of arrows in each configuration as a superscript. Let us perform this by following the steps to determine the electron configuration of elements. Okay, sets of elements. We have sodium, 11, neon for 10, then for boron, which is 5. Okay, for sodium, 11. We have 1s, 1 up, 1 down. For second energy level, we have 1 up, 1 down. Here we go with p orbital. Okay, we need first to distribute every energy level. Okay, for x, y, and z, we have 1 up, 1 up, 1 up. Then that will be the time to apply the downward arrow. Down, down, and down. That for second energy level. Then for third energy level, we have 3s1. We have 1 up. Okay, for neon, which is 10, we have 1 up, 1 down. For second energy level, we have 1 up, 1 down. Then for p orbital, we have 1 up, 1 up, 1 up. Then that would be the time to apply the downward arrow, down, down, and down. Okay, for boron, which is 5, we have 1 up for first energy level, 1 down, 1 up, 1 down, and then for the last, we have 1 up. If the first level of an atom is full, then what would be the total number of electrons in an atom? There would be a total of 2 electrons in an atom. Now that you are familiar with the quantum mechanical model of an atom and the electron configuration, so you are ready for the next lesson, which is the valence electron. Read in advance all about the said topic. We are done in today's lesson. I hope that you've gained something. As what Richard P. Feynman said, the electron is a theory we use it. It is so useful in understanding the way the nature works that we can almost call it real. If you have some questions, feel free to send messages to your teacher through text or messenger. Once again, this is Teacher Jason F. Anthony. Have a blessed day, everyone. Study well for a better future.